Okay, we are live. Hello, everyone. This is TGIK episode 178 on December 10th. Good morning, good afternoon, good evening, depending on where you are. In this session, we'll be going over ClusterClass, the new exciting feature in ClusterAPI, and also the V1 release of ClusterAPI. So first round of introductions. Hi, everyone. I'm Yuvaraj. I started working on ClusterAPI recently, a few months ago. I work with VMware on the Tanzu portfolio, and I'm joined by Vince. Vince, go ahead.
Hi, folks. I'm Vince. I've been in the ClusterAPI scene for 3 years now. If you've seen me around, like, hello again. And I've been at VMware for also 3 years, and I've been working on ClusterAPI since the beginning of time.
Awesome. It's a tradition around here to say hi if you are comfortable with, and also let us know where you're from in the chat. Feel free to say hi, and if everything is in order. So the show notes will be available at tgik.io/notes. Let me put that in io/notes. So most of the links that we'll be accessing and most of the slides that we'll be accessing in this session should be available there. If not, we'll add them later. And if there is any news that you'd want us to cover from the last week, feel free to add it to the show notes and we'll go over them. Oh, we have a few people joining. Hello, Martin. Hello, Wu. Hello, Fabrizio. Hello, Reiko. Thanks, everyone, for joining. Okay, let's go over the news of the week. So let me share my screen. Cool. I hope everyone can see my screen. And please do let us know in the chat if the font size is too small, big, we can adjust it. Okay, we can review. So we just have 2 points, not a lot. So the Kubernetes 123.0 release is finally out. I think it's been like 4 days since it's out. The new features in it have been covered a little bit in the last TGIK session, and we're going to have a full-length episode about covering everything that's in Kubernetes 123 release in an upcoming TGIK episode, which is on Jan 10. So if you're interested, please do tune into that. And the next one is the Kubernetes Contributor Celebration is back again this year. So if you are interested in participating in that celebration, which I highly encourage you to, please do register. Please do fill out the registration form. I think it's in mid-December sometime, 17th, 18th, I'm not sure. You'll have all the details in this page. It's linked in the show notes, and we should be able to register for that. Okay, so the agenda for today. So we will be going over ClusterAPI, a few new exciting features in ClusterAPI, and the V1 milestone release of ClusterAPI. ClusterAPI as a concept has been discussed a few times in various TGIK episodes. We've went over ClusterAPI, all of its providers, the way it's being used in various companies, various products, and so on. But for any new folks who've joined us, Vince is going to do a very brief introduction for ClusterAPI for us. So Vince, go ahead and stop sharing.
Awesome. From a high-level point of view, the best definition I can give for ClusterAPI is to make Kubernetes cluster lifecycle boring. And what that means, like, it depends on, like, sometimes, like, the people you ask. But from a high level, like, Kubernetes is like very complex piece of software. And the goal for the SIG, say cluster lifecycle, is to work like across like a bunch of different points for the whole life cycle. So day 0 operation, how do you define your cluster? Day 1 and day 2 operations, like to just like upgrade your cluster. Before ClusterAPI introduces the concept of load balancer, for example, to upgrade a load balancer was a whole operation. And it was honestly very scary. Like if I remember like when I did it, like just like two years and a half ago, like it was a complex problem where like you had to take into account so many variables. And so what we ended up doing is like automating a lot of these things, like to make sure that like folks are like feel safe from one side, and they're also like there are like so many like health checks and safeguards like throughout the whole system, not just for control plane, which is like definitely an important part of a cluster, but also like for your worker nodes. So we introduced like, for example, machine health checks. The number one point and complaint from our users that we have heard from community is, for example, like the user experience. And that's something that we are working on right now. The 1.0 release that like Yuvaraj will talk in a bit, like about like it's going to contain like a lot of improvements, and we're just getting started, and because we want to improve like how you define a cluster, and like we want to make sure that like defining a cluster is like a really good experience. I often look at kind, for example, for simplicity. We cannot be that simple because of like how cloud providers, you know, it's like very complex, but we want to get there, want to get closer. That's where we're at.
Awesome. That goes in line with the agenda that we have today, which is basically simplifying how a cluster definition looks like with cluster class and so on. So that's like an amazing segue. So yeah, let's look at the, let me share my screen again. Okay, so thank you for covering that, Vince. So the V1 release of ClusterAPI. So ClusterAPI recently went through and had a major milestone release, the V1 release. So it marks that ClusterAPI is finally is production ready officially, and it has moved on to the V1 Beta 1 API types. Cluster API has been operating at this at the beta maturity level for a while, and it's great to see that we are officially having that label and saying that yeah, Cluster API is now V1 and production ready, and it's a work of so many people working. It's a culmination of so many people working towards it, so many contributions from different parts of the community, different companies, and so on. And this new release signifies and demonstrates the growth of the community, the adoption rate of the community, the feature maturity that we have, and the commitment towards it. So there is this amazing blog post in CNCF blog about the V1 release of Cluster API, and there are a few quotes that I found that were really interesting to me. The first one was by Twilio. They did mention that how they've been using Cluster API to run like over 100 Kubernetes production clusters, and how the whole concept of management cluster versus workload clusters help them like scale and manage all of their clusters. And they're really excited about the V1 release, and a lot of quotes from a lot of companies. And then we have New Relic, which basically goes along with what Vince was saying about making about making the Cluster API become a tool so that it makes cluster lifecycle management boring, right? And that's what they touch upon in this, where they say that they basically don't worry about the underlying cloud providers anymore, and instead basically rely on the API types and the declarative pattern to be able to deal with managing clusters, creating clusters, and they are also really excited about the V1 release. So the general trend is that everyone's excited about the V1 release, and we are really looking forward to where the project goes and so on. And before we move on, I would like to give a huge shout out and a huge thank you to everyone who has helped in bringing Cluster API to this point. The V1 release is a huge milestone release. So a big thanks to the entire community for helping us get to this point. The blog post is linked in the show notes. So if you want to take a look, please do go and take a look there. Now that we have the V1 release, like what does it mean to upgrade to the V1 release? So let's just quickly go over the change set that we have, what it means to upgrade, how can we upgrade, and all those things. Right. So the V1 Beta 1 types in Cluster API are actually very similar to the V1 Alpha 4 type. So upgrading from the V1 Alpha 4 version of ClusterAPI, which is basically the 04x release series, to the V1 beta 1 versions, which is basically the 1.0x release series and the 1.x release series, is going to be seamless. It's going to be really, really straightforward. And we have tooling around it to be able to do it. So we have ClusterAPI comes with its own CLI called ClusterCuttle. If you have not taken a look at it, please do go and take a look at it. It's an amazing tool to be able to interact with ClusterAPI and all of its components while you're on a management cluster, right? So it helps you, and that tool has amazing capabilities to be able to upgrade the versions of ClusterAPI. So any management clusters that you have on any of the old releases, you should be able to just use ClusterCuttle upgrade to be able to jump to the newest version. And the one thing that I definitely want to highlight is we do support upgrading directly from V1 Alpha 3 to V1 Beta 1. So you don't have to upgrade to V1 Alpha 4 in between if you directly want to jump to the V1 Beta 1 types. And this support is built into the core CAPI types. And most of the providers also do support jumping from V1 Alpha 3 to V1 Beta 1, but you'll have to take a look at the specific providers to be able to see if they actually do it. Some of the popular providers like vSphere, AWS, OpenShift, they do support upgrading from V1 Alpha 3 to V1 Beta 1. So please do try it out and give us feedback. We're always waiting to listen and see how the project is maturing. So that's the V1 release. It's an amazing. It's a huge release for ClusterAPI, and can't wait to see where it goes. So let's move on to ClusterClass and managed topologies. This is like the newest exciting feature in ClusterAPI that I personally am really interested in, because it solves a lot of UX, adds a lot of UX improvements to how ClusterAPI is consumed and how ClusterAPI is used, and it goes along the lines that Vince has touched upon, is basically making the operations of dealing with a cluster, managing a cluster, becoming really simple and really boring. Right? So to understand ClusterClass, let's just take a look at what ClusterClass means, what managed topologies mean in ClusterAPI, and we can go ahead from there. So I have a few slides here that we can go over, which will give you a visual representation of what we're trying to do. I hope the slides are still visible. I think so. Okay. Okay, so ClusterClass and managed topologies. So let's talk about how clusters are created right now in ClusterAPI. ClusterAPI gives the user access to a lot of extensibility and configurability when creating a clusters using the ClusterAPI types and the kubeadmin, right? So this means that the user has the flexibility to plug in any of the types that they care about and configure a lot of things when creating a cluster. This also means that the user has to create all the objects associated with a cluster, right? So you have to create a cluster, the infrastructure cluster, which is basically an AWS cluster or an vSphere cluster, the underlying control plane, the infra machines, so like vSphere machines, AWS machines, and so on, machine templates, and so on, and the machine deployments, and so on, right? And this could be overwhelming for new users or even for users who just want a cluster, right? And this problem is really exaggerated when you have to repeat the same step again and again for creating multiple clusters. You have to duplicate all the templates that you have. You have to create all the cluster objects, all the underlying resources, like the infrastructure cluster objects, the KCP object, the control plane objects, and all the objects. And on top of that, the users now also become responsible for managing all of these objects, right? Then they have to manage the deployments, manage the templates, manage the control planes, manage cluster objects. And so the problem, the surface of all the objects that you have to manage scales really quickly when you have a lot of clusters at play. And for someone like Twilio, who's using 100+ production clusters, the number of objects that they have to deal with then really grows at a really fast pace. So then how do we solve this problem? And that is where cluster class and managed topologies comes in. So let's look at the first part of the solution, which is basically cluster classes. Right, so we have a bunch of templates that we are using when creating clusters. Right, so cluster class is basically a collection of all these templates put together, so that you don't have to duplicate the templates over and over again. And we also introduce a few new templates like the Kubernetes control plane template, which is basically a control plane template which dictates how the underlying control plane object is supposed to look like. So cluster class, being this collection of all the templates that you care about, is a new resource type a new Kubernetes resource type that's going to be part of ClusterAPI. And this idea of having all the templates grouped into one is really, really powerful, because at this point, the user just has to define how the cluster looks like using the collection of this template just once, and then reuse that over and over and over again for creating n number of clusters at that point. So the surface of all the objects that you have to manage becomes really small. The number of steps that you have to take to create a new cluster becomes really short. And the overall UX of having to create and operate all of the clusters and all of the underlying objects then becomes really, really easy. Right? So yeah, go ahead, Vince.
Yeah, one thing to note here is like, for all these templates, like in the older model that we've seen before, like whenever you wanted to change like a field in a template, like let's just say, like for example, you wanted to change a machine deployment instance type from one instance type to another, you had to go and create another template and then roll it out, which is a really convoluted operation to do that all the time. This is because like most templates are immutable. For rollback purposes, for example, that's one of the reasons that like they were made immutable, and so ClusterClass like will solve that as well.
Awesome, Vince. Thank you for bringing it up. But yes, ClusterClass really is the solution for most of the rollout problems that we have. So now that we have a cluster class defined, which is basically this huge of templates which defines how the structure of a cluster is supposed to look like, how do we use it, right? So at this point, once we have cluster class, the user is now responsible for just creating one object, which is basically the cluster object, which points to the corresponding cluster class that the user wants to use. At this point, the cluster, along with the cluster topology controller that's underlying in CAPI, takes care of creating all the underlying objects that would really be necessary for CAPI to create the full final cluster, right? So the infrastructure cluster, the KCP objects, and all of those things. So, and we have something called managed topologies that is now part of Cluster API and clusters, and that is the second part of the solution. So what are managed topologies? Now that cluster is the single point of contact, a single point of control, and it just references the cluster class. And since the user doesn't have to deal with any of the underlying objects, right? All of the objects that are highlighted in blue are stuff that the user doesn't have to really deal with. The control of being able to create all of these objects and configure these objects, right? The replicas, the replicas to use, the version to use, the metadata associated with it, like labels, annotations, all of this can be now just defined as part of the cluster object. And that topology definition combined with the cluster class definition now rolls out and then becomes part of the entire cluster hierarchy that we generally see in plain cluster API. So cluster class and managed topologies is a UX layer, UX sweetening layer on top of plain cluster API. So once the first reconcile loop finishes, the underlying objects will look exactly similar, like very similar to how cluster API has been working for a while. So they will look as if like cluster API, right? Simple vanilla cluster API that we've seen. And since now cluster is the single point of contact and single point of control for all the operations that we care about, we can do everything from just the cluster object by just modifying the cluster object. So it includes operations like scaling up clusters, scaling up control planes, scaling down control planes, creating machine deployments, deleting machine deployments, scale up, scale down machine deployments. And one of my favorite things to do right now is basically perform Kubernetes version upgrades. earlier with plain cluster API, it used to be a huge orchestration that the user was responsible for performing, where they had to upgrade the versions of Kubernetes on each component at a time. So that would mean going ahead and upgrading the Kubernetes version on the control plane, making sure it's all stable and good, and then moving on to upgrading the versions and machine deployments and so on. Now, with managed topologies, the responsibility is taken up by topology clusters. So the cluster itself will take care of rolling out the version upgrade for all the components associated in the hierarchy for the user. So the UX becomes extremely simple. So as far as the user is concerned, all they have to do is just change one field in the spec, and the cluster's version is going to update automatically. A quick recap and just highlights of what we just covered. So cluster class. Cluster class is just a collection of templates of policies that are needed to be able to create an underlying cluster. A cluster class can be used to create CAPI clusters of similar shape, multiple CAPI clusters of the similar shape, by just creating one resource, and just one resource, which is the cluster resource. And now this cluster object acts as a single point of control for managing your entire cluster, right? So managing all the components in the cluster. So it reduces the surface that you have to interact with when you are dealing with clusters and cluster API. So this simplifies the overall UX of how you have to deal with clusters and how you have to create clusters, manage clusters of Cluster API. But under the covers, it's just plain Cluster API that we are all familiar with, that we all have been using, and that we all know how to extend and how to configure. Before we move on to the demo, let's see if we have any questions. Does ClusterClass help? So we have a question by Rico. Does ClusterClass help with topology awareness? Example, availability zones or rack? I would say kind of yes. So it depends on how you define your cluster class, right? So the cluster class can, it depends on how you define your templates and how you use those templates within your cluster topology. So at that point, underlying, as I mentioned, so since it boils down to plain cluster API, at that point you have the control to be able to set the appropriate labels, I guess, to be able to control where your machine deployments go and where your machines go and so on. Vince, did you have anything to add to that?
No, I think so. KCP, for if you use KCP as a control plane provider, already like kind of spreads out like onto failure domain on its own. The support for each failure domain to go into a specific, for each machine deployment to go into a specific failure domain, it will come in January. There's an issue open. So it will definitely help with that for sure. We just need to add support for it, given that we're trying to start from like a stable set of APIs and then add on top of it. So that's the next thing for sure.
Okay, awesome. There are no more questions. Let's just dive into demo and see how cluster class works and how clusters work. So, okay. I think the font's okay at this point, right? So yeah, so let's just take a look at how cluster class looks like. This is my cluster class. So I have a cluster class here. It's called Docker class. So for parts of the demo, I'm just going to use the Docker provider because it's quick and we can easily iterate on it. But there are some cloud providers that do support cluster class at this point. So we'll also take a look at that. So let's just take a look at how cluster class looks like, right? So the cluster class spec, first of all, has a section for defining how the control plane looks like, right? It then has a reference to the control plane template. Here in this demo, I'll be using the kubeadm control plane. So I have a reference to the kubeadm control plane template. And since this uses an infrastructure machine underneath it, I have a reference to the Docker machine template this control plane object will at that point use. And that defines the control plane section of the cluster class. Then moving on to the infrastructure section of the cluster class. So again, as I said, since I will be using a Docker provider-based workload cluster, I have a reference to the Docker cluster template. Again, as I mentioned, cluster class is basically just a collection of all of these templates, right? Following that, we have a section called workers. This is going to be a list of machine deployment classes that you can define within a cluster class. So each machine deployment class at that point refers to the underlying machine infrastructure machine templates and the bootstrap template. So we have a reference to infrastructure machine template to be used and a reference to the bootstrap template to be used. So I have a list of two machine deployment classes. And both of them are pretty similar. This is an example to show that we can have multiple classes defined within the same cluster class. And as you can see, since this cluster class is a collection of references to a lot of other templates, the other templates that were just referenced within the cluster class are also defined within the same file. So the Docker cluster template, the KCP template, the KVDM control plane template, the Docker machine templates, the bootstrap templates, all of them are defined within the same file. So let's just first create a management cluster. So I'm going to create a kind cluster to use as my management cluster. I have a small script that helps me create kind clusters and also load some HA proxy Docker images onto the management cluster to bypass some of the Docker limits. So let's just wait for that to finish up. And while we are going through, we can also see that the cluster class also allows us to define some additional sections besides just specifying what templates to use. Example, like we can use cluster class to also define what kind of labels should be applied on what kind of annotations should be applied. And all the clusters that use the same cluster class will get the same labels and will get the same annotations at that point. So it also becomes easier for users to like roll out changes to multiple clusters at the same time by just making changes in the cluster class. We'll take a look at a real example of how that's done. And yeah, I have my management cluster ready. So let's just initialize this with the Docker provider. I'm also going to initialize this with the AWS provider for now. And to do this, I'm going to use a local registry of the providers instead of the ones that we have in the public GitHub registries, because I want to use some of the newest features that we have. So before we do that, let's just take a look at the cluster class documentation that we have as part of our Kubernetes, our cluster API book. So there is a section for it which explains how cluster class operates, how you can enable it on a cluster, and so on. Right now, cluster class, the entire feature is behind a feature gate in cluster API. So it's not on by default. So when you initialize your cluster, or if you have already initialized your cluster, you can just go ahead and change the deployment, but you basically have to enable the feature using a feature gate. So we're going to do that right now. So since we haven't yet initialized our management cluster, we'll just go ahead and initialize the management cluster with the features enabled. I'm also going to enable the cluster resource set so that it just simplifies the process of applying CNIs on the workload clusters. So let's just do that. Yeah, so I have the two feature gates set to true, and I'm going to initialize my management cluster with the AWS provider and with the Docker provider. And as I just mentioned, I'm just going to use a local copy of the providers. So this is, I had a slash in between. Let me just clean that. Oh, sorry. Hello, Ali from Iran. Thanks for joining. Yeah, let's just wait for this to spin up and then we can initialize the cluster. Initialize the cluster with the providers that we have, the AWS provider and the Docker provider. While we are waiting for this to spin up, if you have any questions, feel free to ask them in the chat and we'll try to answer them whenever we can. Okay, let me hide this. Cool. Do I have the slash again? I think I have the slash again, right? Let's see. While the cluster is being initialized, let's also take a look at the cluster object on how it uses cluster class right now. So I have a Docker cluster object at this point, right? So the Docker cluster object will look very similar. Most of it will look very similar to how we had cluster objects defined before, right? Before the cluster class and managed topologies came in. The new and exciting part is the topology section within the cluster spec. Within the topology section, we have a reference to the cluster class that we want to use. So as we just saw, we have a cluster class called Docker cluster. So we're just going to reference that. And then we have sections dictating how the cluster is supposed to look like. So we're just going to say we want a cluster that uses the 121.2 version of Kubernetes. We're going to create a control plane with just one replica in it. And we're going to create two machine deployments. The first one is going to use the default worker machine deployment class, and the second is going to use the default worker 2 machine deployment class. And they're just going to be named MD0 and MD1, both with just one replica in it. And this is vastly simpler when compared to how we had to create clusters till date. And as you can see, we're just creating one cluster object, and it is supposed to, and it will take care of creating all the underlying objects and creating the entire hierarchy of all the objects needed for ClusterAPI to be able to create a full-fledged cluster. So let's just go back and see if our cluster is initialized. I think it is. No, it's paste. Cool. So we have all the providers installed, and let me just apply the cluster resource sets so that it takes care of CNI for us. So I have a CRS for KindNet. So all the Docker clusters that I am going to create are just going to use the KindNet, just going to use KindNet as a CNI, so it gets auto applied. Since we went through the Docker Cluster Class definition, let's just go ahead and apply that and just see how that operates. Docker class. No class. So now we have the cluster class. So we have the cluster class. We have all the underlying templates as well. Okay. So let's just take a look at that. Okay. Template. So here are all the underlying templates, right? So we have the cluster class, we have the Docker cluster template, we have the Docker machine templates, the one that will be used by the control planes and the one that will be used by the machine deployments. So now that we have a cluster class defined, let's just go ahead and create a cluster that uses this cluster class. So it's as simple as creating that. So we just created our first Docker cluster. So let's just go ahead and take a look at let's just go ahead and take a look that it created all the underlying objects, right? So we would typically need the cluster object and the Docker cluster object, KCP object, machine deployments. And the fun thing that we have to take a look at is templates. So as we saw, and as Vince mentioned, templates are now, so the topology controller has created copies of the underlying templates that we specified that will be used by this particular cluster. So we have a copy of the control plane template that will be used by this Docker cluster. We have copies of the machine templates that will be used by each of the machine deployments and so on. So at this point, modifying the templates is going to be really easy. So you just apply the changes in your cluster spec or in your cluster class, and cluster topology then takes care of creating a new template, then rolling out the machine deployments with the new template and so on. Let's just set up a few watchers to see that things are going well. Let me just into the dev box that we have. Okay, class. Copy that. So let's set up a watcher on KCP. That's good. Created. Let's set up a watch on machine deployments. Awesome. And let's also set up a watch on machines. Yep. As you can see, cool. Mr. Sharing, yes, I am. As you can see, the cluster is created and it's creating the KCP object. It's ready. It's scaling up the machine deployments at this point. We're just waiting for the nodes to be ready. We can also observe the same states using the ClusterCuttle describe tool that we have. So ClusterCuttle describe cluster docker cluster. I'm also going to look at all the conditions because it gives a better idea about what the status of the cluster is. Yeah. So the cluster, as you can see now, the entire hierarchy has been created that we've been talking about. So we have a infrastructure cluster, we have the control plane created, we have all the machines created, and they are all ready. So we just created our Docker cluster by just creating one resource, which is basically the Docker the cluster object, and everything is at this point ready. And since we know that the cluster object is going to be our single point of contact and single point of control, let's just try to play around with that cluster object and create, like basically modify the topology of our cluster by just modifying that one cluster object. So let's go ahead and do that. So let's edit the cluster object that we have. Let's say we want to just scale up machine deployments, right? So we can scale up the machine deployments, and let's say I want to also scale up the controller. So it's as simple as just modifying this one cluster object, and we should be able to see those changes being rolled out, right? So yeah, the KCP object is now at 3 replicas and it's being scaled up. And the machine deployment that we just changed is now at 2 replicas and it is also scaling up. So if we take a look at cluster, you should be able to see describe is scaling up the control plane and is also waiting for replicas currently available 1. So it's trying to scale up the machine deployments as well. While this finishes scaling up, let's just take a look at a cluster class example for AWS, right? Since we said that AWS also supports it. Right now, not a lot of providers do support cluster class. It's in its very early stages, so providers are still working towards adopting cluster class. But one provider that is ready and it's only available in the main branch of AWS main branch is AWS provided. So if you look at the AWS cluster class, again, it looks very similar to the Docker class that we had. So again, we have a section for control plane, we have a section for infrastructure, and we have the section for workers, except that the templates that are referenced are at this point different. So we have the infrastructure cluster pointing to an AWS cluster template and the machine templates pointing to the AWS machine templates and so on. Let's see if we have any new questions. Is the name of the worker a prefix for each replica? Sorry. If you mean the machines, let's take a look at that. Yeah, so the machines are, so the naming schema is such that it's always the cluster name followed by the name of the machine deployment followed by a random name. So as you can see, so we have the Docker cluster is the name of the cluster, MDZ name of the machine deployment, and then we have a random name generated associated with it. And if you're talking about the machine deployments, again, it's the same rule that follows, right? So we have the cluster name followed by the machine deployments name that we have defined in our cluster objects. So as you can see here, we have defined MD0, MD1. So that's the name of the machine deployment that we have, followed by a random object. And this is so that we can roll out new machine deployments if we have. So if there are any changes detected that the cluster topology reconciler needs to roll out, we'll just create a new machine deployment if it has to, and then delete the old one, and then use the naming schema associated with it.
Yuvaraj, do you want to go back to the cluster object, the new one that we just shown?
Sure.
Yeah. So like just wanted to show like how simple is this. Like the cluster class implementation right now, it's like behind a feature gate, like you have to enable it because it's like the first implementation. But what this enables is truly like the way to, we could have like an inventory in the future. Like we could build like an inventory of cluster classes with each infrastructure provider, pre-validated and like stamped, and then like you have just a way to import them and just use them. So the way to get from a cluster to a functioning one, like from a YAML, it's gonna be like so easy, like compared to what it was before. And the other thing that we have here too is version, right? And we talked about how for the upgrade, how easy to is to do an upgrade today with ClusterClass and manage topologies, where you just can set the version in there and it will roll out safely. It will roll out the control plane first, and then it will do each worker node, well, machine deployment one by one. So the whole cluster will be rolled out like after a certain amount of time.
Yep, that's exactly right. So we'll also take a look at, we'll actually try to upgrade a cluster and see how that rollout looks like. So,
Nice.
um, and right now, the mechanism that we have in cluster topology controller is like a very like safe mechanism. So what I mean by that is it upgrades only one component at a time to be sure that the upgrade goes smoothly. So it upgrades the control plane first, wait for it to make it all like stable, and then goes ahead and upgrades the machine deployments again one at a time. So if you have like two machine deployments, like in this example, it'll upgrade the first machine deployment to the newest version. Only after it is stable will it go ahead and upgrade the second machine deployment. Again, we'll take a look at that maybe right now if this is done. Yep, so we were able to just scale up our control plane and scale up our machine domains just by updating the cluster object. So cluster object truly is our single point of control at this point. So all you need to worry about is just the cluster object, and everything else will be taken care of behind.
So Carlos is pointing out like cross-plane in chat. So just first of all, like you said, like ClusterAPI was using same CRDs as OpenShift machine set. I'm not aware like what OpenShift is doing. I do believe that like they were using machine sets from older versions, but machine set is one layer below of a machine deployment. So machine deployment will actually create machine set, and machine set will roll those out. I'm not sure like about the specific integration of those APIs. I know that they are importing ClusterAPI CRDs for that, but and then crossplane. So ClusterClass was actually like inspired the crossplane like kind of CRD within a CRD definition, where you have like that meta CRD, but we have been wanting to collaborate like on the infrastructure parts with crossplane over time. So those talks are still ongoing. It's really in early stages where like you can just delegate to crossplane to just like do the managing of the infrastructure, and then just tell ClusterAPI, hey, the infrastructure is ready. Here are like your information to continue managing machines, et cetera, et cetera. So yeah, that's kind of like where the integration can come in the future.
Great.
Should we upgrade now?
Yes. So before we do upgrade, I also do want to create an AWS cluster because that takes a while. So we can just keep that in the background and then try to upgrade the Docker cluster. So again, creating the AWS cluster is as simple as just creating the cluster class first, applying the class. So I have the AWS class created. Cluster. And I have the AWS cluster, and it's being provisioned right now. So this is okay. While that's happening, yes, let's go ahead and just upgrade the version of the Docker cluster from v121.2 and then see how it actually rolls out the entire upgrade process. So let's take a look at that. So I'm going to edit the cluster object and let's see. So all I need to do at this point to perform an upgrade is just change the version. So I'm going to jump to the 122.0 version, let's say. Right, so and that's it. So that's all the UX that the user has to do to take care of an upgrade. And now Cluster API along with Cluster Class and managed topologies will take care of bump that up. So as you can see, the KCP, the control plane object of Docker cluster, picked up the new version. It's waiting for it to finish up the complete upgrade. That's why the Kubernetes status version is just at 121.2. And we can also track all of these changes in the conditions of the cluster object. So we can do something like this. So let's just change it to Docker cluster. So the condition that we want to take a look at is topology reconcile, right? So topology reconcile is a condition that reflects if the topology that is specified in the spec has been translated down to the spec of the underlying objects, right? So is the topology updated to all the underlying objects like the KCP object, the machine deployment objects, and so on. And right now it is in the pending state because, as I mentioned, the upgrade process takes care of upgrading only one component at a time. It is for safety reasons. So we can see that the machine deployments have not yet picked up the 122.0 version because they're waiting for the control plane to finish the upgrade to 122.0 version. So as soon as the control plane finishes the upgrade to 122.0, the machine deployments, again, one at a time, will start picking up the control newest version, 122.0. And once all the machine deployments and the control planes spec has been updated to be in sync with whatever is the topology defined within the cluster, then the topology is considered reconciled and this condition goes to true. So this condition is a great way of visualizing how the upgrade process is going on. And of course, you can always rely on just like using the KCP objects, underlying KCP objects and the machine deployment objects to see what the status of the upgrade process is looking like. So right now we can see that the KCP object is still trying to finish up the upgrade. So only one of them is updated and it's trying to roll out new machines and then delete the old machines at the old version. So we can take a look at that here. Yeah. So we can. So as you can see, the Docker cluster, so we have a new version. So we have machine with the new version provision. So once this is ready, it will start scaling down the old versions, as you can see here. And once that happens, it will start moving on to the newest rolling out all the three replicas of the control plane, since we have a three replica control plane. And once this process completely finishes, basically KCP's spec and status match, that is when KCP is completely considered to be ready at the newest version, the process will automatically start moving on to the machine deployments. And the machine deployments are actually updated in the same order that they are mentioned in the topology spec. So this gives us two advantages. One, the order in which the machine deployments are upgraded is predictable, is definable. And two, users can choose to rearrange the machine deployments if they have preference of updating one machine deployment to the newer version before the other. Right? So the machine deployment, the control plane object is going to be upgraded first to the newest version. And while that's happened, and once that is done, the machine deployments will be upgraded one at a time. Okay, there is another question. EKS Anywhere is using CAPI, but not sure if using this new feature. I don't think it is in this new cluster class feature yet, because the cluster class feature is still being built and is behind a feature gate at this point. The newest release of ClusterAPI, the V102 version, is still has very nascent support for ClusterAPI. It doesn't have the fully built features within for cluster class within ClusterAPI. So I think it might be a while before it switches over to using the before providers start switching over to start using cluster class as the default. Docker class is for kind, right? Docker class is the cluster class that I'm using to be able to spin up Docker clusters. So it is going to use the Docker provider that ClusterAPI has. So ClusterAPI has multiple providers. So it has like the AWS provider, the vSphere provider, Docker provider, and so on. So The Docker class that I have is using the Docker provider that I have installed on my management cluster. I hope that answers your question, Carlos. Let's go ahead and take a look at how the upgrade is going on. So we have 2 machines updated to the newest version. We're just waiting for the last one to update. And the AWS cluster. And let's take a look at the AWS cluster. The AWS cluster is, oh, you know what? I need to apply CRS. The AWS cluster needs CRS, right? So that should now make the control plane ready, and then we should be able to get the machine deployments also. Not related to kind. I think I saw KindNet. So KindNet is the one that I'm using to. KindNet is the CNI that I'm using for as a CNI for the Docker clusters, and I'm using Calico as the CNI for the AWS clusters. And now that I've applied the CNI, applied the cluster resource set, which automatically will go ahead and apply the CNI on the target cluster, which is the AWS cluster. You can see that the control plane for the AWS cluster is now ready. The machine deployments are scaling up so that we will have a machine deployment with one. It already has the node. It's just waiting for it to become ready. And once we have this, the AWS cluster is also just ready. Oh, amazing, great timing. The AWS cluster is also ready at this point. Cool. We're just waiting for the last node on the control plane of Docker to finish upgrading to, and once that KCP object upgrades, we'll observe that the machine deployments. Oh, great. Nice timing. So the Docker cluster finished, the Docker cluster's KCP finished upgrading from 121.2 to 122.0 completely. And we can see that the first machine deployment of the Docker cluster picked up the new version. We can see that the Kubernetes version is 122.0. And let's go back and take a look at the conditions. And you can see that the condition also reflects the same information, right? The machine deployment, the MD1 is still waiting on picking up the 122.0. It's still on hold because the machine deployment MD0 is in the process of rolling out, right? Only after the machine deployment MD0 finishes its upgrade to the newest version will we be able to create, will the second machine deployment MD1 pick up the new version. We have a question. How is the AWS VPC created? You have to create it beforehand. I think it is created as part of the AWS cluster object. So as you can see, when we created the AWS cluster, when we created the cluster object that is of type AWS, it underlying creates an AWS cluster object. It underlying creates an AWS cluster object, and it creates like the associated VPC that it needs to be able to create the cluster. And to get a better look, we can actually do a describe on that. So let's just do that. Watch ClusterCuttle, describe cluster, AWS cluster, show conditions, and it creates, so when we create the AWS cluster, it creates the load balancer for us, it creates VPC for us, and it creates all the items needed to be able to create the full AWS cluster. It goes ahead and at that point creates the EC2 instances that will act as nodes for our cluster and so on.
And you can configure all of that through the AWS cluster resource. So you could configure, I think, if I remember correctly, yes, like definitely VPC CIDR, and then like all the subnets you will want available, and things like that. So like those will actually even be reconciled today. So the reason that we're not using crossplane, that like which you mentioned, Carlos, like it's because like this actually was predating, or like this whole system was predating when crossplane was available or like usable for ClusterAPI, and it was not even yet incubated. So at the time, like we just created this whole new thing. But we'll see how it goes. Like going forward, we'll definitely make sure that we'll integrate a little bit more. if the managing cluster crashed, they can recreate the current cluster to continue manage the Docker cluster and AWS cluster in your demo. Maybe. So like you want, if you just delete and you lose all the data, you would not be able to like recover like any of that. But if you do have backups, you can restore those backups, and ClusterClass already has a way to actually like kind of like pause the whole cluster, put everything on files. So there's like a backup and restore mechanics in there, and then you can restore that as well. The other thing that ClusterClass can do is to move management clusters. Let's say that you have a management cluster, you want to put out a service, for example, you want to move all of your management cluster to another one. You could easily move that with ClusterClass. It's like a one-time operation, and like we would expect an operator to do that because it's a kind of one-off and it's dangerous. But yeah, definitely have backups if you're doing this in production.
Yeah. And if you want, we can actually do a move operation of while we have these clusters from one management cluster to the other, and see how that works.
Do it live.
Do it live, yeah, sure. Why not? What
you have
so
you have 122, right? So like I think right now, like could we show actually like what happens? Let's say like I want to downgrade now. I know the answer to this. It's like if we do change the version of that,
sure,
what
yeah,
happens?
let's just do it. So if I want to downgrade the cluster back to 121.2, I think was what I was using before. So let's just try to do that. Right. So Docker cluster. So let's just try to downgrade this to 121.2. Oh. Yeah, it basically throws an error that it is invalid because we currently prevent from downgrading using the cluster because the best way to do I think the right way to do downgrading at this point is to like create a backup of the version that you already were at that point, and then do an upgrade, and if not just restore back to the backup. And that's where Velero comes in, as you were saying, Carlos. Yeah, you can use Velero to do Cluster API backups and restores. And right now, downgrade is disabled by default on all the clusters that are managed by ClusterClass and managed topologies.
I noticed that we have the AWS cluster around now, right? Like that should be created.
We do have the AWS cluster. Do we want to upgrade that as well? Sure, we can do it.
Let's try to upgrade to 123 directly. Let's see what happens.
Sure, let's do that.
And this is the fun stuff of doing it live,
I don't know if the AWS images for the new version are published yet, because the new version was just released a few days ago, but let's see. You know what, we can check that, right?
You can, and you can do ClusterAPI AWS docs, and it should be in there.
Yeah.
Oh yeah, or that.
3.0. Failed to lay. Okay, so we don't have. There is none.
Well, I actually wanted to show that you can't actually jump two versions at once. So because we're on 121, this should be refused, if I remember correctly, unless it won't.
I don't think it will. I think it will just try to accept the version, and since the MI is not found, the rollout will fail.
Okay.
So let's not do that. Yeah, so the Docker cluster is completely upgraded to the new version, and we have the AWS cluster ready. Are there any questions? Kind images are available. Kind images are available. So yeah, we can try to upgrade it to 123. So I'll need to, do we want to do that? Sure. I don't know if I have the 1.3 kind images available locally, so I might hit the Docker rate limiting issue. Let's see. Okay, while that either processes or fails, let's see what else can we talk about. Tooling around cluster class, right? So right now we have a lot of tooling around cluster class. That's so cluster API itself comes with a lot of tooling right now. So example, ClusterCuttle is a CLI that we've been using to like show conditions and initialize and perform cluster API upgrades and so on. So all of these tooling has been upgraded to also support cluster class. So one of the key things that ClusterCuttle enables is users to do quick start, like quickly jump into and create cluster classes, create clusters from scratch with just a kind cluster, with just a bootstrap cluster and so on. And let's just go over that. So let's take a look at how quick start looks like right now, and then we can see how that would look like with cluster class in play. So this is the documentation that we have for ClusterAPI and the quick start flow. So once we have the management cluster, which in our case is a kind cluster, and once we've initialized, we've already initialized our AWS provider and our Docker provider. And the thing that most people use is something called ClusterCuttle generate cluster. So let's take a look at that. So ClusterCuttle. So ClusterCuttle generate cluster helps us create the cluster YAMLs that we've been seeing till now. So the cluster YAML that needs to be applied onto the clusters to get a full cluster. And the ClusterCuttle generate command has now been upgraded to be also able to support generating cluster YAMLs that use cluster classes. So let's take a look at a standard example of how a cluster looks like when we use the ClusterCuttle generate commands. Output looks like when we don't use cluster classes, right? So let's do class ClusterCuttle generate cluster. Let's do Docker simple version. Machine does one, and the flavor that I'm going to use is development, I think. Let's just check that. So as I mentioned, I'm using a local repository to be able for all of my ClusterCuttle commands. So we can actually take a look at how that local repository looks like. Cluster dev repo. And within my infrastructure Docker, I have two flavors, one called Topology and one called development. The Topology flavor uses cluster class, but the development flavor uses the old style cluster. So let's just take a look at that and see how that looks. And let me just point to the local repository that I have. Marker simple.yaml. Okay. I need to specify the provider because I have multiple providers installed. Cool. So the Docker simple cluster.yaml looks like the one that we're all familiar with. It has a cluster object, Docker cluster object, the machine name. That's basically all the objects in the hierarchy that we need to create one cluster. So this is the standard way of creating clusters that we had till now. And this is how and since the development flavor that we uses a standard way, it turns out to come out, the output looks very similar to that. Now let's use a flavor that uses cluster classes instead. So we have a cluster topology that uses the Docker simple cluster. Oh, the name's confusing, but anyway. So we have a cluster class called Docker simple. So it references a cluster class called Docker simple, But the point to note is it is not, that particular cluster class is not available on the cluster at this, on the management cluster at this moment. So let's see how that works out. So let's call this Docker topology. And I think the flavor is called topology. Yeah, so as you can see, what it tried to do was it tried to create the cluster class. It tried to check if the cluster class that's already the machine templates and any of the things that are already available in the cluster, and it just like what the command does is it goes ahead and checks within the existing management cluster that we are operating against and sees if there are any cluster classes that need to be installed that are not already installed, if there are any templates that need to be installed and not already installed, and so on. So it is warning us that a template with this name, the Docker machine, the Docker worker template, is already available on the cluster. And if we try to apply this new cluster, it might conflict with it. So there are safeguards in place for us to be able to avoid any foot guns. That helps us to make sure that we don't modify the cluster class or modify the underlying templates in the cluster class by any by randomly applying another template and then causing ripple effects. Because changing cluster classes can have ripple effects because multiple clusters can be using the same cluster class. So if you change anything on the cluster class, all the clusters will at that point get affected. So it's a very powerful tool, but at the same time, it's also it's a potential foot gun that the users have to be very cautious about while using. And one of the features that we put in place is something called rebase. We can talk about that a little bit, which is basically if you want to roll out, if you want to be able to change the cluster class, but you want to be safe and you don't want to affect all the underlying clusters. The idea behind rebase is basically create a duplicate of the cluster class and then just modify that one cluster to point to a different cluster class. So right now we have our Docker cluster pointing to the Docker class. So if we create another cluster class with, say, let some of the templates modified or some of the worker deployment classes modified and so on, we can just rebase the class to point to a new one, and the topology reconciler will try to restructure or reconcile the existing cluster to match the underlying cluster class that it has now been updated to point to. This is also something that needs to be done carefully because again, there are safety checks in place. For example, there are something called compatibility rules that both the cluster classes have to match. So an example is you can't change a cluster class that was originally, let's say, an AWS cluster class to a Docker cluster class, or you can't change a Docker cluster class to an AWS cluster class. And there are some safety checks like that in place. Again, to make sure to avoid any foot guns and make sure that the process of creating clusters and rebasing clusters is as simple as possible. So let's see if okay, the KCP is getting upgraded. Nice, I think. Yeah, it's probably just failing because I don't have the image locally and we're probably hitting the limits, the Docker rate limiting. So what I'm going to do, I'm going to delete this cluster right now. I'm also going to delete the underlying cluster class so that we can see how the generate cluster command looks like when there are no conflicts associated with it. So let's just delete that. Okay, and we should be able to see that the conditions also reflect. Grouping. Oh, it's already gone. It's already gone. That was fast. Okay, so let's also delete the cluster class. So we just have the Docker clusters. Okay. Neat. Cluster class, Docker cluster, Docker class. Okay, the cluster class is deleted. So now we don't have anything for Docker clusters. So let's try to rerun this command and see what happens. Cool. Docker topology. You know what? Let's open this in the other one so we can compare it. So Docker simple, Docker topology. Great. So the Docker simple example that we generated using ClusterCuttle generate cluster command that doesn't use a deployment flavor that has that is using cluster class basically creates all the hierarchy, like all the objects that are needed in the hierarchy to create the cluster. So cluster, Docker cluster, and so on. But when it comes to let's say the cluster class associated with it, right? When we are using a flavor that uses cluster class, right? So we have the cluster object in it, but since this cluster at this point references a cluster class that's not already installed or not already available on the cluster, it basically adds the entire definition of the cluster class and all of the templates into the YAML, right? So at that point, the flow is just going to be like, Docker topology. We can just apply this YAML. It creates the cluster class. It creates all the associated templates, and it also creates the cluster. Now let's try to repeat the same thing. Let's try to create another cluster called, let's call it Docker simple 2. Using the same flavor, using the same topology flavor, which would mean that it uses the same underlying cluster class, and then see how the output of this is going to look like. So Docker topology 2. At this point, you can see that the output just has the cluster object. So the UX of creating the second cluster is as simple as just basically creating the cluster object, because the ClusterCuttle command is smart enough to figure out that the underlying cluster class that it references is already installed on the management cluster. So it doesn't have to add that to the output template. And all it needs is just the cluster object. So from here on, as long as you're using a cluster class that's already installed or that's already available on the final cluster, all you need to do is just create that one cluster object, and you can just apply this at this point. Okay, topology. And that's it. So we just created another Docker cluster called Docker simple 2. Docker simple 2. Yep. Yep, and they are being provisioned. So with that, some other tooling that we have to take a look at, we can probably take a look at, is the ClusterCuttle move command that we were just talking about. So if you wanted to move all of your, let's say, move your management cluster from one to the other, the newest ClusterCuttle move command also is aware of how to deal with cluster classes. So it makes sure that cluster classes are moved before clusters and so on, so that when you move a cluster to the new management cluster, it doesn't fail, and it is aware of the hierarchy that's associated with cluster classes and clusters, and automatically takes care of doing them. And for the move operation to operate, how the move operation works right now is it pauses all the clusters associated and then performs a move from one management cluster to the other. So let's just wait for this cluster to also reconcile completely before we perform the move operation. In the meantime, let's see if there are any questions in the chat that we can answer. Does it blend? I'm not sure if I follow that. Kind images are available. I don't see any new questions. I think they're good. Vince, did you have anything to add at this point? Are there any other points that you would want to highlight?
The only thing I want to add is just like this is so great. Like it's just like such a stepping stone right now. Like to start. This is truthfully Cluster API using Cluster API to create these clusters, like automating like the whole chain of reaction. And the powerful thing for us that like this enables us to do is like each single component can still live on its own with its own lifecycle, but all the controllers the Cluster API offers and all these CRDs, they cooperate with each other to make sure that the cluster goes up and running. And then now the cluster class with cluster class and cluster managed topologies, not only the cluster object becomes the single point, but it also becomes like a more useful object that ties everything together, but also defines and informs like what the topology of that cluster should look like. And so I'm excited to see like where we go from here, like for, as we go into 2022.
We have a question from Heywood. Does this or Cluster API support OpenStack? So I believe there is an OpenStack provider for Cluster API. I am not sure if they have adopted ClusterClass yet. I would guess not yet. But Vince, is that
Yeah,
right? Or
I'm
did
not
they all?
sure.
Yeah.
I don't know.
Okay.
I haven't looked at it yet.
Okay, let's do a move with an AWS cluster and two Docker clusters. So I've created a second kind cluster that's going to act as our target management cluster that we want to move to. And before we perform the move operation, we also have to initialize the second cluster with the same set of providers that we have on our first cluster. So let's do that. So once that's initialized, let's perform the move operation and see if it works. The context has switched. The reason we're not able to see any of the objects right now is the target context is the second cluster and nothing's installed on the second cluster. That's why the watchers are not able to see any of the objects yet. Okay, so let's just switch over to the original context. Config, use context, client copy test. Yep, so all the objects that we have on the original cluster are still there. So let's just perform the move operation, right? So let's look at documentation for move. It's just cluster move the target kube config, right? So let's get the kube config and get kube config name. Then get a second GT. Second GT dot kube config. Okay, that's okay. Kube config. Okay, it's working. So before we can get clusters, we're still on the first one. So cluster move to kube config, second kube config. So it is performing the operation, and you can see it is moving the 3 cluster objects that we have, and it's moving the 2 cluster class objects that we have. And that's it. We just finished our move. So if we just switch, if we do clusters on the original cluster, we'll have nothing at this point. But let's use the new one. Use context. Okay, get clusters. We have our clusters moved from the source cluster to the target cluster and the cluster class associated with them and the Docker cluster templates and okay, get and all the templates associated with all the objects that we care about. Machine templates. Yeah, so we just performed a move operation, and similarly, other tooling within Cluster API, especially the cluster kernel backup, which was brought up before, is also upgraded to support Cluster Class. So Cluster Class is going to be one of the components that it does backup and restores. And again, the hierarchy is hierarchy of which objects need to be restored and backed and restored while restoring the objects of cluster class versus cluster is built into the tooling so that it takes care and it is aware of the right sequence of objects to restore when restoring from a backup. There are some questions. Can you show the access control service accounts for those CRDs in your kind so that some people can read but not update them? Access control. So you want to see the RBAC policy. So is that it? Access control service accounts. Those CRDs, kind cluster. So this uses the same. So this uses the same. As I said, this is just a UX wrapper on top of the existing cluster API tooling that we have. So it doesn't change. Just so we're on the same page, it doesn't change any of the RBAC rules associated with the kind cluster associated with the services that Cluster API itself uses or the Cluster API containers use and the RBAC policies associated with them to be able to interact with creating the clusters and creating the underlying objects of the clusters and so on. Any other questions? OpenStack, I think we have already gone through that. Okay, so that's cluster class and managed topologies. I think we've gone through most of the topics that we wanted to go over and highlighted some of the topics. So just to reiterate on what the new cluster class feature and what managed topologies mean is. So cluster class and managed topologies is this UX layer on top of the plain vanilla cluster API that we all know. It massively simplifies the UX of being able to create clusters and being able to manage clusters and so on. It solves a lot of headaches of having to operate and manage on a lot of underlying objects. Instead, the whole control goes to just one cluster object. And as Vince was saying, this extends and the future for cluster class could look like when we initialize the providers as we were doing in this. Maybe they also come with some cluster classes baked in. So at that point, the UX of creating the first cluster is just as simple as creating a cluster resource, right? And that's it, because the associated cluster class is already baked in, and you don't have to worry about creating any of the underlying objects and so on. Vince, did you want to add anything else before we go into what's next for cluster class?
No, go for it. Let's go.
Awesome. So now that we have the basic foundations of cluster class and managed topologies and how we would want to operate and how we've already seen that they can manage and operate clusters by just using one point of control. What's next for cluster class? Like, what is the next set of work that we're working on right now? So one of the things that I want to show is the AWS class that we've used. The AWS class that we have used right now relies on a lot of defaults. Like, for example, it defaults to the instance type of t3.large and it defaults to the SH key of TGI. I've already had this SH key and so on. So it relies on a few defaults within the cluster templates associated with it, and it defaults to like the region and so on. So what if we want the cluster to be able to also configure these values, right? Let's say the cluster class doesn't define the region, doesn't define the associated SH key, but let's say we also want the cluster to define them, right? So in those cases, there is this whole idea of a patch engine. What that means is we can define a cluster class and associate with certain patches, which basically are applied when creating the underlying cluster object, right? So, and these patches have taken as input a set of variables and a set of templates, apply the variables on top of the templates using the patches defined, and then create output templates, which are then used by the cluster. Let's take a look at how cluster class with patches looks like. So, AWS Class Advanced. So we have the same default cluster class that we had, which references to a control plane, which references to an AWS cluster template, and so on. But if you look at the AWS cluster template, it doesn't have an instance type value already defined in it, right? So this has to be replaced, and this can be replaced with the value that we specify. And what that looks like is within the clusters, we're going to have this new section called patches, which defines a list of patch operations, basically JSON patch operations that can be performed on top of the template. And a cluster that is using a cluster class that define patches is going to look like AWS cluster this. And if you look at the cluster that is using a cluster class with patches, it's going to look like this, where it specifies to the cluster class that has more advanced configurability, and then it specifies a bunch of variables that it wants to replace. So it basically says, okay, the SH key name is TGI. So the machine type is T3.large, and so on. So with this, the cluster class becomes even more configurable, even more extensible, and we'll talk more about patches in a future TGIK episode, because patches is a full thing on itself, and there are various kinds of patches that really take cluster classes to the next level in terms of configurability and extensibility. So we'll do another deep dive into cluster class and the patch engine associated with cluster class in another TGIK episode. Another thing that we would want to take a look at, the next thing is machine check support being built into cluster class. So right now, ClusterAPI does come with machine health check supports, and the cluster class and the clusters that we've built during this demo can be integrated with machine health checks. Basically, you need to define a machine health check configuration with the right labels to be able to configure machine health checks on the machine deployments that you have. But there is this proposal about integrating machine health checks directly into the cluster class so that it all becomes one cohesive piece, right? So while defining the cluster, you also define the machine health check criteria for the cluster and for the associated machines, and so on. So I'm going to link a pull request. I'm going to link the proposal for how machine health checks are going to look like within cluster class. So if folks are interested, please go take a look at that. So that's with cluster classes and all the features that we've covered. I think we've covered all the points that we wanted to talk about. The demos also showed how ClusterAPI, along with cluster classes, massively simplifies the UX of being able to create clusters using just one object, and being able to operate on the cluster object with just by handling and editing with just one object, which is the cluster object, and how the future of the cluster class project looks like. Before we close out, Vince, did you have any final thoughts that you wanted to share?
No, this looks great. The patches that you've shown, Mike, they're just the start. Like they're usable right now on the main branch. Like we haven't released a full version yet, but patches is going to enable like a lot of use cases. Right now they're like a little bit limited, like as in like you have to define a cluster class, and they will your users like will have to define them on your cluster object. So like you just put the variable in there and the cluster will reconcile like everything. In the future, like what we will do is probably like also enable like other ways to define these variables and patches, but also like improve the visibility of it. So like when you change a variable, like you probably want to know what happens into the cluster, right? Like is this going to roll out everything? Is it only going to roll out like partially? And like I do believe ClusterClass actually already has like a dry run command for cluster for ClusterClass rollout. So I'm not sure if you want to talk about that a little bit, but yeah.
So the dry run support for ClusterClass is being built right now, and for ClusterClass. So I don't think we can do a demo right now in this because I don't have the build.
No, just talk about like what.
Yeah, sure. So regarding dry run, so as I was mentioning, so when you change, let's say, the cluster object or the cluster class object associated, since it generally has ripple effects, because changing the cluster topology, let's say, goes ahead and updates the machine deployments and so on, right? Or goes ahead and updates the KCP object and so on. So the whole idea behind dry run is within cluster Cuttle, we want to be able to provide a dry run option so that the user can dry run a change and then see the list of things that will get modified, the list of things that will get updated, and also get a sense of, are these updates compatible? Let's say, for example, as I mentioned previously, I want to change the cluster class from one type to the other, or make changes in the cluster classes that the template changes from one to the other, and see how this would affect all the clusters that I have. So you can dry run that change using Cluster Cuttle, and it should give you an overview of what all will change, like the list of clusters that will change, the objects that will get modified because of the clusters that will get changed. And it should also show you information about, is this change compatible? Is this change not compatible? Will the change be rejected? Will the change be accepted? And so on. Similarly, we're going to have dry run capability of being able to edit, modify cluster on making changes on cluster objects, and then see how the output is going to look like. Basically, see how the machine deployments will get updated, see how the templates will get rolled out, and so on. That feature is being built in, so stay tuned to see how that turns out. And while we are on the topic of Cluster Cuttle, as we saw, Cluster Cuttle has the ability to also operate with cluster class based cluster templates, right? So we've seen how when we point to a cluster that uses a cluster class, it goes ahead and brings in the cluster class and adds it to the template if it's not already installed, and skips it if it is installed, and so on. So this is largely dependent on the providers, because the providers are the ones who ship the template YAMLs and also the cluster class definitions. So for all the providers out there, so we have updated the Cluster Cuttle provider contract on how you can use, or how you can opt in to also provide templates that cluster templates that rely on cluster classes and cluster topology. So please do go ahead and take a look and see if any of the items that are already defined in the contract need to be adjusted, or how you can opt into using cluster classes and make it a more streamlined mainline feature within your own provider. With that, Vince, does that talk about dry run, the one you're asking about?
Yeah.
Okay, awesome. Great. So I think we've covered all the points that we wanted to talk about. We've went through ClusterAPI V1 release. We've done an overview of Cluster Class. We've seen how Cluster Class works with clusters, and how the cluster structure changed because of the introduction of the new managed topologies and cluster classes. Hope everyone gives it a try and sees how it, and then gives us feedback on the overall feature. You can find the CAPI team on the usual channels, so the Slack channel, the GitHub projects. We can open issues and discussion threads there, and you can also reach out to us in Kubernetes Slack. I think the channel is called ClusterAPI, and you can find us there. So we are all eager to get feedback on the project, and we are excited to see what everyone's going to do with ClusterClass, this new feature in ClusterAPI. With that, I think we can. I think we are done with this episode of TGIK. Hope everyone had a good time, and thank you for joining.
Awesome.
Thank you for joining.
Have a good weekend, everybody.
Have a good weekend, Al. Bye.